Welcome to our 2023 Bay Area Hack submission, Neuralang. Neuralang is a compiled interoperable scripting language built for machine learning. Neuralang is a compiled language with support for interoperability with any LLVM language, for example C, C++, Haskell, Rust, etc., with a focus on machine learning. Neuralang ships with several features, for example interoperability, allowing you to attach this code right here into any language that you want, typing, allowing for more readable code, and C-level speeds, so you don't get any bottlenecks because of some bad Python package, you know? Anyways, the inspiration for this project is that all modern-day machine learning is done on Python, making it not very extendable. Good luck trying to have Rust and Python communicate with each other, which I assume in a Rust API or whatever. You're going to be banging your head on the wall for hours. So, Neuralang seeks to solve this by making a scripting language built in LLVM, allowing anybody with knowledge in most modern languages to have access to machine learning in your program without the need of creating multiple programs to have concurrent machine learning. So interoperability is possible because of LLVM's IR. So basically, you can convert most LLVM compatible language, for example C, Rust, whatever, I listed them later, into intermediate representation. Since our language also compiles to that intermediate representation, we can just link it together and have your language call this function, and then it can run a machine learning program, right? So an example of this is our standard library. So our standard library with our layers, nodes, and the input-output, right? It is all coded in C++. However, we used the Clang, what was it called? The Clang compiler to compile it down to IR, which is shown right here. Since our language also compiles to IR, we just simply link it together, and bam, we have C++ and Neuralang interoperability. So we have that. And now for the compiler structure. So basically it's split into three parts: the front end, which contains the AST and lexer, AST stands for abstract syntax tree, the middle end, which contains the passes, and the back end, which converts the code into LLVM IR. The front end defines how the LLVM syntax works. So for example, if I were to go into the if statement, so if has like two parts, if and else. We didn't add if else because that's basically an extension onto if. So let's just say if there's a condition, then do this, else do that, right? And the backend, which basically just defines it in a higher level fashion into assembly code, that it'll convert it into assembly code. So we're defining it into a higher level syntax because we gotta tell LLVM, hey, this function exists, we gotta convert it. So that's what this function here is for. So some challenges that we ran into is that LLVM's documentation leaves too much clutter. It's really bad. We spent like 10 hours one day trying to debug this one bug that wouldn't let our IR work, and it hurt my head. However, some accomplishments that we're proud of is that we made our own language in 2 days. It has basic functionalities and at least what we think. If you think this is good syntax, I think this is good syntax. It is good modern day high-level syntax. So we learned how to make our own language interpreter that can compile down to IR, which can later be compiled down to machine code, creating an executable, which is pretty cool in my opinion. And moving forward, we plan to add a lot more functionalities and a lot of more predefined classes to, let's just say, make another model. For example, let's just say you want a classifier instead. So yeah, basically a predefined classifier in Neuralang, which can interact with any LLVM compatible language, which is crazy in my opinion. Also, we hopefully to add more features and built-in functions to help newer users. Thank you for listening to this. I gotta go submit the project.